Well, everyone, welcome to the August Virtual Planetarium with Pete Lawrence and myself. And we will start, as ever, with the inner solar system and the planet Mercury, which is an evening planet but is really badly placed at the moment. It reaches greatest eastern elongation on the 9th of August. It shines at a pitiful magnitude 0.4. Point 0.4. It sets miserably 40 minutes after sunset, so then gets worse. So basically, really, Mercury is out for the count.
Out of the way. And Venus equally badly positioned at the moment, because Venus is now, from the UK at least, it's no longer visible in the evening twilight. You've got to pick it up during the day when it's visible with the sun in the sky. So you've got to be very careful when you pick it up to do that. The planet reaches inferior conjunction on the 13th of August, when Venus will line up with the sun. Now, what does that actually mean? Well, it means it's going to line up with the sun and have the same ecliptic longitude. That's the gridded coordinate system, which is based with the ecliptic as its equator, effectively. So it will line up with the sun on the 13th of August, and it doesn't line up perfectly, because if it did, we'd have a transit of Venus, and we're not going to have another one of those for a little while.
It's the next century. It's more than a little while.
I think it's 2117 or something like that.
It's well away.
So this time it's either going to move above or below the sun. In fact, on the 13th of August, it'll move to the south of the sun, and it will be separated from the centre of the sun by 7.7 degrees, which is possible to view, but you do need to be extremely careful. You shouldn't look for this visually, because you will probably damage your eyes, and we don't want to be responsible for that. So don't look at it visually. The best way to do it is to use a camera.
Yeah.
And then the risk is there to destroy the camera. If you destroy the camera, it's on you, because we told you to be really careful. But you do need to double check everything when you are that close to the sun, because it's so easy to make an error.
It is. So basically, if there's any doubt at all in your mind, don't do it, fundamentally.
That's very good advice. And what would you see if you did do it? Well, on the 13th of August, it will have a phase which is 0.9%. So that's an incredibly thin crescent. And that crescent will be almost an arc minute across, which is really large. If you could see it, and obviously shouldn't look with the eye to try and find it, but if you could see it, that's about on the threshold of the angular resolution of the eye. And that's an interesting thing, isn't it? When it's in the evening sky, normally, well, I say normally, when it's in its crescent form, close to inferior conjunction, but you can see it in the evening sky, it's a good test to see whether you can actually see that crescent. And it's difficult because it's very biased. It is difficult.
It is difficult. I've convinced myself I can see it, but I'm not really sure, because the shape of it kind of blends into that sort of spiky effect that you can see when objects are very bright. So it's quite tough to be able to see it. But as you say, Pete, this is the end of this elongation for Venus. After inferior conjunction, it will re-emerge into the morning sky.
Yes, it will.
And should start to be visible in the morning sky really from the last week of August.
Very quickly, actually, it re-emerges, because, of course, it's on part of its orbit, which is closest to Earth, so it's moving really fast. And if you, on the 31st of August, shining at magnitude minus 4.3, which also helps, of course, Venus will rise 1 hour, 50 minutes before the sun, which is quite remarkable, really.
It is, given how close it was. So, so that'll be a good thing to watch out for. And then, again, the Venus will now be in the morning sky and go through the same phases that it went through in the evening sky, but in reverse order. So, yes, that'll be fun to watch.
Well, the next planet out is stuck. It's no longer moving. It's just stuck next to the sun. This is an effect that you get with Mars after opposition or months after opposition, it seems to get into a position where it just doesn't move and it just remains there, getting fainter and smaller all the time. And that's where we are at the moment. At the start of August, Mars will shine at magnitude plus 1.8, but be really hard to see low above the western horizon as the sky is darkening. A slender 5% lit waxing crescent moon will sit 2.8 degrees right and slightly up from Mars on the 18th of August, but even seeing the moon at that time will be a challenge. So Mars is sort of off the menu, isn't it, at the moment?
It is, and gone really until August next year, really. So, yes. So, next planet out then, we're into the gas giants, Jupiter.
Yes.
Brilliant morning object, actually. Magnitude minus 2.3 in Aries. Against dark sky, Jupiter reaches 23 degrees altitude on the 1st of August, but by the end of the month, this is really rapidly improving because the planet reaches an altitude of almost 50 degrees as seen from the centre of the UK, almost overhead, Pete.
Let's call that overhead.
Let's call that overhead. So that will be good. And we will have great views of Jupiter now over the next few months. Well, for quite a few months, actually. Normally about half a year.
Yes.
So it will be very good. It's a great planet to look at if you've got a small telescope. You can see little bands going across it. You can see the 4 Galilean moons. And large telescopes just seem to reveal ever more detail.
And if you get a night of really steady seeing, it can be quite astonishing to look at. It's worth pointing out, by the way, that when we said let's regard this as overhead, it's not actually going to be overhead. It's going to be 50 degrees up, which is just over halfway up the sky. But from recent years, it'll feel like it's almost overhead. It's worth pointing out as well that the last quarter moon will appear near to Jupiter on the morning of the 8th of August. And the moon next to such a bright planet is always quite a stunning sight.
It is. It is always quite a nice thing to see. But yes, so Jupiter, brilliant telescopic object. Go out there and have a look. Moving on to everyone's favourite planet Saturn. So this planet reaches opposition this month on 27th of August. Saturn is at opposition. That means it's opposite to the Sun in the sky and due south at midnight. So on the 1st of August, Saturn reaches quite a high position under relatively dark skies, but this will improve throughout the month. And its highest point in the sky is 25 degrees up, as seen from the centre of the UK.
Yeah.
That may not seem like much, but compare this with what was it, 18, 17 degrees a few years?
It got down to about 14, I think.
Yeah.
It was about as low as something like that.
I had a brief, during those miserable years, I got a 14-minute view of Saturn as it passed between houses, and that was it. So this is much better.
Much better indeed. And of course, because we are at opposition, as you say, on the 27th of August, there is an effect to look out for, which is called the opposition effect with Saturn. And it basically occurs because all the particles which make up Saturn's rings, they're not particularly large particles, but several meters or so across, typically chunks of water ice, they cast shadows. And those shadows, when Saturn is away from opposition, can be seen. You can't see them individually, but you can see the net effect of them. And that dims the rings, basically. But as it goes to opposition, the shadows line up with the particle that's casting them. So the shadow becomes hidden behind that particle, and all you see is the bright face of the shadow-casting particles. So the rings appear to brighten, and that can be quite noticeable, can't it?
I find it very marked, actually. And what tends to happen is the middle ring, the B ring of Saturn's got 3 rings, the outer A ring, the B ring in the middle, and the darker crepe ring, C ring at the edge there. I find that details in the B ring kind of disappear visually a little bit at opposition, because the B ring is so bright because of the effect you've just mentioned. So, and it really is a couple of days before and a couple of days after opposition, you notice this opposition effect. So if you don't get a clear night on opposition night, the night before, the night after, you should be able to see it.
One thing that is working slightly against us at the moment with Saturn, as it gets higher in the sky, of course, is that the tilt is reducing quite markedly.
Yes.
It'll only be about 8 degrees, so the rings will appear relatively flattish won't they?
Yeah, they will. But the interesting thing there is that we'll be able to see a lot more of the southern hemisphere of Saturn
Yes.
than we have been before because of the tilt, as you mentioned. Saturn's rings have been covering up the vast majority of the southern hemisphere on Saturn. So we've had no idea what's been going on there during this time. And now the rings have closed up a bit. We should get better views. We should be able to see the southern equatorial belt, which I don't think I've seen for about 8 years on Saturn. So,
and I'm presuming that when the rings, because the rings cast quite a big shadow onto that hemisphere of the planet, as they move out of the way, that will change the weather.
Yeah, well, but there's all these effects to play. For a start, the shadow you've just mentioned, I saw that properly for the first time last year after an absence of many years because the rings were tilted so far open. You couldn't really see visually that shadow. But now they've tilted quite a long way again, and now they're quite shallow. The shadow of the rings on the globe, as it's called, will be very, very noticeable, and it will be interesting to see if there's any effects on the local climate of Saturn's weather as a result of that.
Absolutely. Okay, well, let's carry on out further into the solar system. So we've got the planet Uranus, which is best to see at the end of the month, around about 4 o'clock BST, when it'll be at an altitude of about 47 degrees in a southeast direction. So that's a planet which is getting better. It's also worth noting that by the end of August, as it gets to sort of almost 50 degrees altitude under dark skies, Jupiter will be closing the gap between it and Uranus, shining at minus 2.5. Jupiter will sit 7.6 degrees west-southwest of the planet. Actually, Uranus is more or less sort of in between Jupiter and the Pleiades.
Yes, so it's another easy way to find it if you haven't seen it. Neptune reaches a 35-degree altitude when due south under darkness towards mid-August or so, but it shines at magnitude 7.8, so definitely optical aid will be required.
Yeah. Okay, well, some of the special events which are happening this month, we've got Comet C 2020 V2 ZTF is currently around 9th magnitude, and in the region of sky to the south of Uranus and Jupiter. So it's sort of moving slightly to the west of the head of Cetus, the sea monster, or whale, however you want to see it. So I would recommend looking in the magazine and getting the details on that and seeing whether you can see this comet. And of course, it's probably worth mentioning as well that the first part of August marks the end of noctilucent cloud spotting season. Although I think last year they were seen right into the middle of the month, but who knows?
We have to wait and see. On the 1st of August, we have the full moon. This occurs at 1831 UT or 1931 BST near lunar perigee on the 2nd of August. The first of 2 full moons this month. This is the perigee full moon for 2023. I suppose it'll be given a name. Every full moon each year seems to be given a name. Do you finding this?
Yes, let's call it Percy perigee full moon.
Oh, that's a good one. Shall we start naming half moons? Should we get that going?
Harvey the half moon. Okay.
Yes. Okay. On the 9th, we've got a lovely scene on the eastern horizon around 2 a.m. BST or 1 a.m. UT. Jupiter, the Hyades and Pleiades clusters, all together with a lovely waning crescent moon. So that'll be quite pretty to look for.
That'd be lovely. Well, the big event, of course, for August is going to be the Perseid meteor shower, which is my favourite shower. I started observing that in 1977, Paul.
Ancient as the shower itself.
And the formation of the solar system. So the Perseids they actually have peak activity in the early hours of the 13th of August. So that means the night of the 12th of August into the morning of the 13th of August will give probably the best view. But also you've got the night of the 13th of August into the morning of the 14th of August giving a good view as well. And it's really worth following up those nights after the 12th, 13th, because the moon will be out of the way. The moon is reaching its new phase on the 16th of August, which couldn't be better.
No, it's really gone for a bit of time. That gives you time to see just how the meteor activity is behaving after the peak activity. So, as you say...
There's an interesting effect actually with the Perseids. I've seen it in the sort of the mainstream news broadcasters. They will mention big meteor showers like the Perseids in the years when the moon is about, and people go, "Oh, I didn't see anything," because the moon is about, and then they seem to think that because everybody's moaned about it, it's not a good shower. So when you get a year when the shower is really good, they don't cover it.
No, doesn't help, does it, really?
So this year is really good.
Yes.
So long as the weather stays good, the shower should be absolutely fantastic. So do go out there and try and see it. Just give yourself lots of time. If you want to limit your observing time, the best time to look for Perseid meteors is after midnight UT. So 1 o'clock BST, and that's not a long time to go from then until dawn, because dawn is relatively early as well. So and the reason why that's better is because the Earth will have turned on its axis, so it's basically facing the meteoroids coming head on into us, so the trails appear brighter and you see more of them.
So that's definitely worth a go, and let's hope for clear skies for the Perseids.
Yes.
On the 24th, as it approaches its setting point, the 54% lit waxing gibbous moon sits 3.2 degrees west of Antares this evening, so that'll be a nice one to watch. And then on 31st, second full moon of the month, although this is not technically correct, is it? It's often referred to as a blue moon, but that's not
right.
quite
No,
right.
A blue moon has a definition. It's I think it's in the Farmer's Almanac, actually. That was where it was originally defined as being an extra full moon. I think it's the third full moon in a season, which has 4. That's what they defined a blue moon to be. And another magazine, I believe, actually printed or misinterpreted the definition and printed that the second full moon in a calendar month was known as the blue moon. Now that's probably easier to understand than the original definition, which is why it's become popular to call the second full moon in a month a blue moon. But technically that isn't correct, and it won't be blue anyway.
No, so very strange terminology, and we should indeed stick with the original definitions, as we do with Sky Night magazine.
Yes, I should point out that it might be blue if we have a volcanic eruption.
Might.
Well, it's sulfur in the air is what makes it appear blue.
Okay. Well, we'll see if that happens. Okay, well, the night skies of August are an interesting place. If you go outside and have a look out there, you'll see dominating the view to the south is the bright summer triangle. And this is formed of 3 bright stars. On the left, marking the left-hand corner of the triangle, is Deneb in Cygnus. On the right-hand side, we have Vega in Lyra, and down at the bottom, we have Altair in the Eagle. All 3 of these stars are bluish-white in colour, and quite distinctive.
Yes, they are. For our Southern Hemisphere friends, I know a few in the Southern Hemisphere do listen to this, that means Deneb is in the northeast, Vega is in the northwest, and Altair is in the south.
We call it the summer triangle, but it's actually visible for a lot of the year.
It's visible right through to December.
But it's best placed in It's best placed in summer, so
yes,
that's fair enough. Of the 3, the constellation of Cygnus the Swan is probably the most impressive pattern. It's certainly the most easily recognisable, looking as it does from the Northern Hemisphere as a big cross. Indeed, often it is informally known as the Northern Cross and really stands out. We have Deneb at the top of the cross, and then right at the bottom we have that beautiful binary star or double star, Albiro, which is made of 2 components, a beautiful turquoise colour star and an older red giant star.
Stunning, isn't it? And
it is.
Of course, Cygnus contains a very special object for you, of course, because was it the first object thought to be or postulated to be a black hole, Cygnus X1?
I believe so, yes. I believe this was one of the first pieces of evidence that general relativity wasn't just some obscure theoretical physics. It was an accurate theory of gravity. So yes, it is. It's you can't see it, of course, but one can see the effect that the black hole Cygnus X1 has on its companion.
Yes.
And by doing observations of it, you can put limits on how big that object has to be, and as we can't see it, it must therefore be a black hole. But yeah, there's some other interesting objects of interest as well. I follow the variable star Chi Cygni, which isn't it's not far from our biro. This is a red giant star that expands and contracts and can get quite bright. So that's another nice object to take a look at.
Well, the centre of the Northern Cross is marked by the star Saturn, which it's a fairly easy to see star with the naked eye. In fact, all of the stars in the Northern Cross are fairly easy to see. The star to the east is called Gina, and Delta Cygni, which I was always under the impression was called Rook, which it was for a while, but that has now been officially named. That's called Phawaris.
All right. Why was it renamed, or do we not know?
It's the wisdom of the International Astronomical Union.
Right, okay. Moving on. The cross actually does dominate the sky this time of year, but this is a good chance to try and find the Milky Way, because the Milky Way, which is one of the spiral arms of the galaxy, passes really down the middle of Cygnus.
Yes, it does.
And if you've got a dark sky and a pair of binoculars, it's worth scanning through that part of the sky, because it really is quite fabulous. And you can see there's a load of dust between us and that part of the galaxy, so part of the Milky Way appears to be blotted out due to the starlight being blocked by dust, and that really is... It
splits in two, doesn't it? It's called the Cygnus Rift. In fact, that's the best part of the Milky Way to see from the UK.
Yes.
And if you're in the southern hemisphere, you have a beautiful view of the core of the galaxy, and that is absolutely stunning. For us in the UK, it doesn't really get above the horizon by enough to do it justice, but if you can see it in a sky where it's above the horizon, it looks like a computer simulation.
Yes, I've got to try and see that at some point. I'm told
it's stunning.
It's quite spectacular. Okay, well, to the north of Cygnus, also just to the north of your zenith, you'll find the strange, slightly shaped constellation of Cepheus the King. You think it's kind of like a house shape, don't you?
It looks like a child's drawing of a house. Yes, a classic, or one that you would do.
Oh, thank you. Yes. It actually contains some interesting objects.
Yes, it does.
Delta Cephei, for example. Now, this is a prototype of a class of star known as Cepheid variables, and these are very important objects because their absolute luminosity, in other words, how much energy that they can give out, is linked to the period of which it changes. So all you have to do is measure the period of how the star is brightening and know its magnitude, and from that you can work out how distant the star is. And that's particularly useful when these stars lie in other galaxies, because then you can use them to measure the distance to other galaxies.
It's a very, very
useful.
Important. It's not the first one discovered, is it? Wasn't it?
I don't think so.
Eta
I'm not
Aquili.
It might have been. I'm not sure it was the first one.
It was the first one registered, I think, registered as that class of object, which I think anyway, which is why it's given such prominence, and it's the sort of, as you say, the prototype for Cepheid variables, as they're called. The other important star, of course, in Cepheus is Mu Cephei, or Herschel's Garnet star, which is a distinctly orange star, and that's variable as well. It looks rather insignificant, actually, and varies in magnitude between plus 3.6 and plus 5 over a period, a couple of years, 2.5 years or so. However, in real terms, it's an absolute monster, estimated to have a radius which is 1,500 times larger than our own sun, and a luminosity about 350,000 times higher. That's quite impressive, isn't it?
It is. So quite a bit of a monster star, really. I gather it sits at the centre of some faint nebulosity.
Yes, it does.
Which I don't think you can see visually, can you? It has to be photographed.
It does, and it's a large area of nebulosity, and in there is the famous elephant trunk Elephant's Trunk Nebula, which is a popular target for astrophotography as well. But no king, of course, would be complete without his queen, and Cepheus's better half can be seen rising in the northeast around midnight. And that's Cassiopeia, the seated queen. It's an interesting constellation, actually, because the seated queen, the depiction of the seated queen, because she is the mother of Andromeda, and she said that Andromeda was more beautiful than any other living creature, which really angered the gods. And for her penance, she was put in this seat, which goes around the pole star, and as it does so, for half the time she's upside down. So she's depicted clinging onto the seat so she doesn't fall out.
I had never noticed that. It's interesting, isn't it? Because there's this inverse relationship between the Plough group of stars that we call the Plough saucepan in Ursa Major, and the distinctive W shape of Cassiopeia.
Yes,
means that when one of them is high, when Cassiopeia is rising, the Plough is setting, and vice versa. So it's quite interesting that the relationship between the two.
Yes, it is, and of course the Milky Way, the northern part going through the north of Cygnus anyway, passes up through Cepheus and into Cassiopeia. So it's a great place to scan with binoculars to see all the clusters, etc., which are there. So I think we'll probably draw to a close there, and just remind you to go out and have a look at the wonderful Perseids this year if the weather plays ball. Fingers crossed it does, because we deserve a good meteor shower. So all that remains to say is thank you very much, Paul.
Thanks, Pete.